In this video, we are going to talk more about the agile software engineering methods. Let's begin with a high-level comparison of two popular agile methodologies, Scrum and Extreme Programming, or XP. Scrum is described as a flexible framework for managing product development in teams of 5 to 8 members. It's particularly useful for teams that are cross-functional and self-organizing, work in short iterative cycle called sprints. XP shares many values with Scrum, but it typically applied it to smaller teams of 2 or 3 developers. It focuses much more on technical excellence, such as coding practices, automated testing, and continuous integration. Unlike XP, Scrum does not prescribe any specified technical practices. Instead, it focuses on how teams organize their work using rules like Scrum Master, Product Owner, or events such as daily stand-ups and sprint reviews, and artifacts like Product Backlog. XP, on the other hand, dives deep into the technical practices. It prescribes how to write better code, how to test early and often, and how to avoid integration issues. So, in summary, Scribe provides the management structure while XP focuses on engineering practices. Many teams actually use a blend of both to balance strong technical practices with effective project organizations. Let's go over some of the most essential elements in Scrum. These 4 components, product owner, product backlog, and development team, form the foundations of the how Scrum teams operate. The product is the actually software system being developed by the Scrum team. It includes all the features, improvements, and bug fixes delivered throughout the project. In Scrum, the goal of each sprint is to move closer to a version of the product that is potentially shippable or usable. In the other word, the product is not just an end goal, it's what evolves throughout the sprints and should be incrementally usable at each stage. The product owner is a critical team role in Scrum. This reason and this person defines product features based on user and stakeholder needs, prioritize items in the product backlog, ensures that the product being done aligns with overall vision and user requirements, and participates in testing and overviews to give quick feedback. So think of the product owner as the voice of the customer. They are not just a manager, but a decision maker guiding what gets built next. The product backlog is a dynamic, prioritized list of work the team needs to complete. It includes features or new capabilities, bug fixes, technical tasks, user requests, or suggestions. So the backlog is continuously refined and updated as new requirements emerge or priorities shift. And the development team is a small, cross-functional, and self-organizing group, usually 5 to 8 people. They are responsible for designing, building, testing, and testing the product. So the team organizes its own work without relying on traditional manager. These are the people actually doing the hands-on work of creating the product. So they collaborate closely and adjust their process as needed to meet sprint goals. In this slide, it introduces more core components of a Scrum's in iterative process. Each of these plays a key role in ensuring the team is moving forward consistently and efficiently. A sprint is a time box development cycle, typically 2 to 4 weeks. During a sprint, the team selects a set of prioritized tasks from the product backlog and works to deliver a usable product increment by the end of the period. The time box is fixed. This means even if all planned tasks aren't finished, the sprint ends on time. So think of a sprint as a mini project. It has a goal, a plan, and a deadline. So it's right. Rhythm helps teams maintain momentum and deliver value continuously. But the Scrum meeting, or we can say daily stand-up, this is a short daily meeting using usually 10 to 15 minutes long. Each team member answers three questions like, what did I do yesterday? What will I do today? And are there any blockers? The goal here isn't to solve problems, it's to surface them and keep everyone in sync. Many teams stand up during the meeting to keep it brief and focused. The Scrum Master is like the coach or facilitator of the Scrum process. They are not the team leader or manager. They serve the team by removing obstacles, ensuring Scrum practices are followed, supporting continuous improvement. And you can think of a Scrum Master as the guardian of the process. So their role is to protect the team from disruptions and help them work more effectively and potentially shippable product increment. So at the end of each sprint, the team aims to deliver a working, tested, and potentially shippable piece of software. This does not mean it must be released immediately, but it should be ready for release if desired. So this helps avoid the trap of it's almost done. In Scrum, you either deliver something that works or you move unfinished work back to the backlog. And about the velocity is a measure of how much work a team can handle in a sprint, typically based on story points or completed backlog items. It's used for planning future sprints, helping teams estimate how much they can realistically commit to. So velocity isn't about pursuing teams to go faster. It's about forecasting and pacing. Stable velocity helps teams make reliable delivery promises. In Scrum, two leadership rules play a vital part in guiding the team and ensuring the product is built in the right way. These are product owner and the Scrum Master. So the product owner is responsible for keeping team focused on the right work, the work that delivers the most value to users and the business. They are often the same person as the product manager, especially in smaller teams. One of their biggest responsibilities is shielding the team from distractions such as side requests from other departments, technically interesting but not essential work, frequent scope changes without business justification. So their job isn't just to prioritize the backlog, but to keep the team aligned with the product's purpose and ensure that effort is spent wisely. The Scrum Master acts as the process coach, a person who makes sure the Scrum framework is being followed effectively. In many teams, the Scrum Master is also a member of the development team, especially in smaller groups where rules often overlap. In practice, they may also take on some project management duties, such as tracking sprint progress, facilitating communication, handling external reporting. While they may help the project management task, their primary role is to empower the team, not to manage it. The Scrum Master ensures that the team can focus on delivery without bottleneck or confusion. Um, On the one of the core structures in Scrum is the concept of a sprint, a focused development cycle where a team works toward delivering a usable piece of software. So let's break this down. What is a sprint? A sprint is a fixed length cycle, usually 2 to 4 weeks. Through some teams may go up to 6 weeks depending on the context. During this period, the development team commits to a set of items from product backlog and focuses only on completing them. Think of each sprint as a self-contained mini project. So it has a goal, a plan, and a deadline, and at the end, we expect to see something real, a working piece of software. So what happens during a sprint? The team conducts daily Scrum meeting, short check-ins to track progress, identify and remove blockers, adjust plans based on evolving understanding. So these stand-ups help the team stay aligned and transparent about what everyone is working on. So these meetings aren't for problem solving. So they are for surfacing issues early so the team can act quickly. At the end of the sprint, the team should deliver a potentially shippable product, increment, so a working feature or improvement, fully tested and integrated, ready for release if needed. So even if the business chooses not to release it, the increment should be of high quality and deployment ready. This enforces discipline and keeps the code-based production worthy at all times. This diagram represents the heart of a Scrum. So it's iterative development cycle. Each cycle, called a sprint, follows a structured loop, and the entire process repeats until the product is complete or goals are met. So let's look through step by step of this cycle. From start, we go to review product backlog. So we begin by looking at the product backlog, a periodized list of features, bugs, improvements, and technical tasks. The team collaborates with the product owner to review and refine this list based on the current goals, feedback, or changes in the requirement. So after that, we move to the select items to implement. So the team selects a set of backlog items for the upcoming sprint. These should be high priority and feasible to complete within the sprint timeframe. And the next plan sprint. So in the sprint planning meeting, the selected items are discussed in more detail. Tasks are broken down, estimated, and assigned to the team's sprint backlog. After that, we have the sprint officially start. During this fixed length cycle between 2 to 4 weeks, usually the team works only on the selected sprint backlog item. And each day, we reach to the Scrum phase. So in each day during the sprint, the team holds a Scrum meeting, a stand-up meeting to sync progress, raise blockers, and adjust their daily plans. And then in the develop software, the team actively develops the assigned feature to fixes focusing on delivering work software. And in the test software, as features are completed, they are immediately tested, ideally using automated testing and continuous integration practices to ensure quality. And by the end of the sprint, the team delivers a potentially shippable product, increment, a function, and tested piece of the software. And here, a sprint review is held to demo the product increment, gather feedback, and identify what worked well or what could improve. So based on the feedback and the results from the sprint, the product backlog is updated, and new items may be added, and prioritize may shift. And from here, the next sprint begins, continuing the cycle of continuous improvement and incrementally development. triangle captures the core benefits of Scrum. Notice how it's centered around three crucial dimensions: product, progress, and people. So let's explore how Scrum supports each of these. In the product sections, Scrum breaks the product down into small, understandable chunks. So these chunks are typically defined in the product backlog and delivered incrementally through sprints. This approach allows stakeholders like customers or product managers to better understand and provide feedback on what's being built. Instead of seeing the product all that once at a time, at the end, stakeholders are involved throughout the process, which builds clarity and confidence. Also, even if requirements change frequently, Scrum accommodates this well by allowing reprioritizing in the next sprint. In the progress section, Scrum ensures visible progress through time boxed sprints and frequent deliveries. Customers see on-time delivery of increments, not vague promises or long development phases with no output. And in the third part, the people, Scrum fosters better team communication by encouraging transparency. Everyone can see what everyone else is working on. So it also builds trust between developers and stakeholders through continuous interactions and delivery. Over time, this improves team morale and creates a positive culture grounded in transparency and accountability. To build effective software, we need to understand who is using it and how they are using it. This slide introduces two important concepts in user-centered design: rules and personas. A rule defines what actions a user can perform within a system and what they have access to. Rules are functional categories like teacher, for example, can create assignments and grades, or rule of a student who can submit homework and view feedback. Rule or administrator who can manage users and settings. So every feature in your application should be role aware, meaning the system must check the user's role before allowing access. Think of rules as permissions tied to a user, what they can do, see, or modify in the system. A persona is a fictional character that represents a group of users who share similar traits. A good persona includes demographic information like age, job, education, and behavioral traits like tech savviness, usage habits, the goals, what they want from the product, and also it include pain points, what frustrates or hinders them. Personas help the team visualize and emphasize the real users. It's not just about making features, it's about making the right features for the right users. It's important to remember that a single persona can assume multiple rules. For example, budget conscious Ahmed, which we will review it in the next slide, this example, might be a user who tracks expenses, but also a reviewer in a financial app approving budgets. This insight reminds us that the real users don't fit into the just one box. They interact with the system in multifaceted ways. As you can see here, we have the example persona in a finance management software product. We can call it as budget conscious Ahmed. We have a background of this persona. For example, his age is 28, occupation, marketing coordinator, tech savvy, but prefers user-friendly interfaces. We have the goals to track his spending and saving easily, to create a budget that helps him save for a vacation, to receive reminders about upcoming bills. And also, there are some challenges. Feels overwhelmed by complex financial apps, struggles with keeping track of expenses in real time, and needs motivation to stick to his budget. So once we have defined a persona like this, we don't just leave it as a document. We actually use it to guide real design and development decisions. This slide walks us through exactly how that happened. So we have the first step, feature prioritization. So knowing Ahmad's goals and challenges, the team decides to prioritize a simple budgeting tool that doesn't overwhelm users, or a user-friendly interact that aligns with Ahmad's preference for ease of use. So this ensures that the product features are aligned with the user needs, not just developer assumptions. We are not just building cool features, we are building the right features for the right users. Also, for design decisions, for example, Ahmad dislikes complex multi-step processes, so the user flow is optimized to minimize the number of steps he has to take to input expenses or manage his budget. So this persona reminds designers to reduce friction and focus on intuitive design. And also for user testing, when selecting test participants, the team looks for individuals who match Ahmad's demographic and behavioral profile. This helps ensure that the testing phase yields relevant and actionable feedback. So we are not guessing if our solution works for our target user. We are testing it with people just like them. And in the marketing strategy, the team creates messaging that appeals to young, budget conscious professionals, highlighting features that align with their values and struggles. From the first line of code to the final marketing post, everything is shaped by understanding the user. This diagram shows how we go from a high-level understanding of users through personas, all the way down to the actual features we build in the software. It's a step-by-step process that ensures what we build is grounded in real user needs. So we have at first personas to scenarios. We begin with personas which represent typical users. These personas inspire scenarios, short narrative describing how a persona might interact with the software. For example, budget conscious Ahmed opens the app and wants to quickly check if he's overspending on restaurants this month. So this is a scenario based on his persona. Next, from scenarios to stories. These user scenarios are then translated into user stories using the format, specific format. We will review the format in the next slide. So, for example, it says, as a persona or role, I want to go so that reason. So we will review this specific format in the next slides. So stories make scenarios actionable for the development team. So for example, for our example, Ahmad's scenarios might become, as a user, I want to see a spending chart by category so that I can understand where most of my money is going. Next, from stories to features. So each feature addresses a user story and represent a piece of the product the team can build, test, and deliver. The story about visualizing spending may lead to a feature like a dashboard with a monthly pie chart of expenses. Let's talk about one of the most essential artifacts in Scrum, the product backlog. This is the master to-do list for the entire product, and it drives all sprint planning and development work. What is the product backlog? So the product backlog is a dynamic list of all work that needs to be done to deliver a complete software product. It evolves constantly. Items are added, updated, reprioritized, or removed based on feedback and changes in project direction. It's not just a list we create once and forget. The product backlog is living. It changes as the product and users evolve. Product backlog items or PBIs. Each task on or entry in the backlog is called PBI. These items can include new product features, for example, user login, reporting dashboard, user submitted requests like change password functionality. It could include core development tasks like setting up database, building APIs, and also it can include engineering improvements like refactoring code, improving load item. So basically, if it takes developer time and contributes to the product, it can be in the backlog. The backlog must be prioritized regularly by the product owner. Items with higher value, urgency, or technical dependency are moved to the top of the list for implementation in the next sprint. So Scrum is all about doing the most valuable work first. The product backlog helps us keep that focus clear. This slide covers how to properly write user stories in agile development. What makes a good story, how to define when it's done using acceptable criteria, and how spikes differ from user stories. So we typically write user stories using this format. As a rule, I want to goal, so that reason. So let's break this down. Role. What is the user? For example, buyer, teacher, admin. The goal. What do they want to do? And the reason. Why do they want to do it? So what benefits do they gain? This format keeps the team focused on user value, not just functionality. It answers who needs something, what they need, and why. All well-written user story has these characteristics. Not technical, which is written in plain language from the user's perspective. Independent, so they are self-contained and not dependent on other stories. Valuable, provides real value to the user or customer. Negotiable, flexible, and can be discussed or revised with the team. Estimable, small enough to estimate effort and time, small and testable, narrow in scope with clear outcomes that can be verified. This makes stories easier to prioritize, develop, and test. You don't want huge, vague stories. You want clear, actionable items. Um, about the acceptance criteria, so these are specific conditions that must be met for a story to be considered complete. They are often bullet points or testable requirements. For example, the user can enter expenses in under 5 steps, or the system should send a confirmation email after registration. Acceptance criteria make expectations clear for both developers and testers. They reduce ambiguity. And about the spikes, spikes are technical tasks that don't directly deliver user value but are needed to support development. For example, setting up a database or researching an unfamiliar API. So spikes are not user stories. They are internal, behind the scene work, and we track them in the backlog because they still require time and resources. Here, there's real examples of product backlog items illustrating the different types of work we track in Scrum. And in this slide, it includes features, user requests, and technical spikes. Each play a role in shaping the product. So let's begin with the stories that describe functionality from the user's perspective. First one, as a teacher, I want to be able to define new assignments in every class I teach. So this is a feature and it adds direct value to an end user. So you can estimate effort and write clear acceptance criteria like the system must allow the teacher rule to define and assign a new assignment. Second one, as a parent, I want to be able to view my child's work and assessments made by their teachers. So another feature with clear user value. So an example acceptance could be the parent can see all final exam grades and click to view their breakdown. Let's review some user request example. As a teacher of young children, I want a pictorial interface for children with limited reading ability. This is a user submitted request based on accessibility needs. So it reflects a specific audience's usability requirement and could become a backlog item or spark a spike for feasibility research. So these types of requests help teams make the product more inclusive and user-centered. Let's review non-user facing technical tasks. So, for example, establish criteria for assessing open source software. This is a technical investigation or planning activity classified as a spike. Also, refactor user interface code to improve understandability and performance. So that's again a code improvement, important for maintainability, but not directly visible to users. And the last example, implement encryption for all personal user data. An engineering improvement that increases system security. Again, not something users see, but critical to system integrity. We call these tasks spikes because they support development by addressing uncertainty, performing research, or improving internal infrastructure. They don't produce user visible features, but they are essential. Not every backlog item is immediately ready to be implemented. In Agile development, we manage our product backlog items or PBIs by progressing them through clear readiness states. This ensures we are already working on the right things at the right time. Ready for consideration stage. So these are early ideas, features or tasks that have been suggested but not yet evaluated in depth. They may represent a product vision or a stakeholder wish, lack details or a clear value, be excluded later based on team discussion. Think of this as the idea stage, a parking lot where we store possible backlog items until we are ready to evaluate them further. Next, ready for refinement stage. So these items are now on the radar for near future development. The team agrees the item has value and should move forward, although more details are needed. User stories might be incomplete, requirements could be vague, dependencies may be unclear. So in this stage, the team works with the product owner to clarify scope, break large stories into smaller ones, and prepare the item for sprint planning. And ready for implement state. So now the item is fully defined and detailed enough for development. This means the item is clear, testable, and estimable. Dependencies are identified and manageable. Acceptance criteria are agreed upon. So at this point, the item is sprint ready. The development team can take it into a sprint with confidence without needing to stop and clarify. The product backlog isn't just a list that sits there. It needs to be actively managed and maintained throughout the project. This slide shows 4 key activities involved in keeping the backlog relevant and useful: refinement, estimation, creation, and prioritization. So let's check each of those. In the refinement, it's also called backlog grooming. Refinement is when the team revisits existing PBIs, product backlog items, and clarifies vague items, splits large stories into smaller, more manageable ones, and also updates acceptance criteria or dependencies. New PBIs might also emerge as a result of these discussions. Refinement ensures that stories are ready when needed and no time is wasted during sprint planning. Next, estimation. So during or after refinement, the development team estimates how much effort each PBI requires. And this could be in story points, person hours, or ideal days. The estimates are used for sprint planning, capacity forecasting, and velocity tracking. Actually, estimation is not about perfect accuracy. It's about consistency and realistic planning. Next, creation. So new PBIs are added continuously. These might include feature requests from users or the product owner, updates to existing features, engineering tasks like code cleanup, process improvements such as tool evaluation or testing strategies. So anyone on the team can suggest new items. What matters is that each one is captured, discussed, and properly detailed before implementation. And the last one, prioritization. So backlog items are reordered to reflect business value, user needs, technical dependencies, risk, or urgency. So this is mainly the product owner's responsibility. Through it may involve feedback from developers or stakeholders. So agile prioritization is dynamic. The backlog should always reflect the current top priority so that the next sprint delivers maximum value. So in summary, refinement sharpens the backlog, estimation quantifies it, creation grows it, and prioritization aligns it with product goals. These 4 activities are the backbone of effective backlog management in Scrum. This diagram visually shows how the product backlog evolves as the Scrum team applies backlog management activities, refinement, estimation, prioritization, and creation to transform it into a better and more actionable list. So from left side, we see product backlog, initial product backlog. So we start with a simple list of PBIs, PBI 1, 2, 3, and etc. These may have been captured early on and are likely high level or incomplete. So this is often the state of the backlog right after a brainstorming session or a product kickoff meeting. Lots of ideas, but not yet ready for sprint planning. In the middle, we have the 4 activities of refining. So as you see, we can, for example, in this example, we see that it breaks larger PBI, for example, PBI 1, into smaller, more manageable items, PBI 1.1 or PBI 1.2. After the estimation, it will add effort values to PBIs to help with planning and velocity tracking. So as you see here, PBI 2 it just changed to PBI 2E and PBI 2 3E, so E as was estimated. And the prioritization reorders items so that the most valuable or urgent tasks rise to the top. So PBI 4 and 5 might stay the same or change in position. And after the creation, new PBIs are introduced based on new ideas or evolving requirements. So, for example, PBI 6 appears in the revised backlog. So each of these steps enhances the backlog quality and usability, making it more than to-do list. It becomes a planning and alignment tool. So this revised backlog, as you see, is what the team will use for sprint planning. It's actionable, well understood, and aligned with the current priorities. When planning and managing sprints in agile development, we need to estimate how much work a task will require. This slide explains two common approaches: person hours and story points. So each has a different purpose and context. So effort required uh, based on person hours or person days. This method measures actual working time, how long it would take one person to complete the task from start to finish. It expressed in hours or days. For example, if a task takes 5 person hours, that's 5 hours of effort by one person. This is not the same as calendar time. So if 5 people work together, they might complete a 5 hour task in just 1 hour. So effort measures work, not duration. Multiple people working in parallel reduce duration, but not the effort. Story points are a relative estimation method that considers task size, complexity, required technology, and the degree of uncertainty or risk. Rather than assigning a time value, the team compares each task to a business task. For example, a login page might be a 2 point task. So a task that's twice as complex might be 4 points. One that's half as complete could be 1 point, for example. So story points help teams estimate work even when exact time is unknown. They encourage thinking in terms of difficulty and risk, not just clock time. So why use both? Person hours are useful for capacity planning and workload balancing. Story points support velocity, tracking, and long-term planning in Agile. So most Agile teams use story points during sprint planning and reserve person hours for tracking actual time spent. Okay, so let's walk through the sprint life cycle, which includes three key parts: planning, execution, and review. We always start with sprint planning. So this happens at the very beginning of the sprint, usually on the first day. The team looks at the product backlog and decides together which tasks or features they can realistically complete during this sprint. These selected items become the sprint backlog. So this planning session doesn't take more than a day, and the goal is to live with a clear plan and shared understanding of the work ahead. So then we move to sprint execution. This is where the actual work happens. The team focuses completely on getting those sprint backlog items done. Now, here is something important. If something doesn't get finished, the sprint is not extended. Agile is all about fixed length sprints. So anything incomplete just goes back to the product backlog, and the team may choose to tackle it in a future sprint. At the end of the sprint, we have the sprint review. This is like a show and tell what a stakeholder with the stakeholders. So the team demonstrates what they have built, ideally something that's functional and potentially shippable. Feedback is encouraged because it helps guide the direction of future development. And after that, the team holds a short meeting called a retrospective. This is just for the team to talk openly about how the sprint went. what worked, what didn't, what should we do it differently next time. It's a chance to continuously improve not just the product, but the process. Okay. So let's take a closer look at how all major Scrum events fit together in a typical sprint cycle. This diagram gives us a nice overview from start to finish and then back again as the process repeats. We begin on the left with the product backlog creation. This is where the product owner collects all potential work items, features, bug fixes, improvements, anything that might be valuable for the product. Think of this as a master to-do list for the entire project. Next, we move to sprint planning, which kicks off the sprint. The team selects a handful of those backlog items, just enough to reasonably finish within the sprint, and forms the sprint backlog. That gives them a clear focus for the next couple of weeks. Now we are in the heart of the process, the sprint itself. During this time, the team works. Just a minute. Now we are in the heart of the process, the sprint itself. During this time, the team works on the items they planned. You will notice that product backlog grooming happens during the sprint. This is also called backlog refinement. It's when the team and the product owner meet, usually once or twice during the sprint, to clean up and clarify future backlog items. That way, the sprint planning sessions goes more smoothly. As the sprint wraps up, we go through a series of closing events. First is the sprint review. The team shares what they have completed and demonstrates the product to stakeholders. This is shown here as the stakeholder demo. And it's a change to real feedback, check progress, and confirm whether the product is headed in the right direction. Right after that, we have the team retrospective. This is just a Scrum team, no stakeholders. The goal is to reflect on how the sprint went and find small ways to work better next time. Maybe communication needs improvement, or maybe the estimation process was off. This is the time to bring that up. And finally, we loop right back around and move on the next sprint. Agile is all about this repeating, continuous cycle. Plan, build, review, reflect, and improve. Um, okay, so now let's talk about one of the most familiar and practical parts of a Scrum, the daily Scrum, also called daily stand-up. This is a short meeting that happens every day, usually right at the start of the workday. The idea is simple. The team gathers for a few minutes to get aligned on what's going on. Think of it like a morning huddle before a game. Just a quick check-in to make sure everyone's on track. What's the purpose? Mainly three things: to make sure everyone is on the same page, to raise any short-term issues or blockers early before they slow the team down, to tweak plans if anything needs to shift based on new information. During this meeting, each team member shares three quick updates, what they worked on since the last meeting, and any problems or blockers they are facing, and what they plan to do today. It's not just talk. We also update the sprint backlog during or right after the Scrum. Finished tasks are marked as done, and if new work pops up, like a technical issue or a change in priority, it might get added as well. Then before wrapping up, the team decides who's going to work on what that day. That might include choosing backlog items or tackling technical research called a technical spy. Now here's something important to keep things effectively. This meeting should be short and focused, ideally 5 minutes or less. Many teams even stand the whole time, literally no chairs, to avoid getting too comfortable and dragging the meeting out. That's why it's called a stand up. So the daily scrum helps the team stay coordinated, spot problems early, and move forward smoothly. It's a small investment of time that really pays off in team productivity and communication. Now, even though Scrum itself doesn't require any specific technical practices, there are a couple of things that are really important if you want to maintain high quality during development, especially with a fast moving sprint. Let's look at the two main ones: test automation and continuous integration. First, we have test automation. In Agile and especially Scrum, we are building and delivering software quickly and in short cycles. So manual testing isn't always fast enough. That's why it's a good practice to automate your test. Teams typically build a suite of automated tests that can run anytime and check whether the core functionality still works. This way, if you make a change today, you don't have to manually check every feature. You run the test and they tell you what broke, if anything. It gives you speed and safety at the same time. So then we have continuous integration or CI. This is about how we handle code changes in traditional workflow. Developers might work in isolation for days and then try to combine their work later. And that can lead to big integration headaches. With continuous integration, as soon as a developer finishes a chunk of work, they immediately merge it into the main code base. But here is the catch. You don't just merge code, you also test it right away. In that way, if anything breaks due to the new code interacting badly with the rest of the system, you catch it early while it's still easy to fix. So even though Scrum doesn't officially list these practices, teams that want to move fast and keep quality high really benefit from using both automated testing to validate work quickly and continuous integration to make sure everything plays nicely together. Let's talk about something really important in Scrum, something that helps us all stay clear on what finished actually means. That's the definition of done. A common problem in software teams is when one person says, I'm done with this task, and someone else finds out later that it wasn't really done. Maybe it wasn't tested or it never get integrated. So in a Scrum, the team creates a shared checklist called the definition of done to make sure everyone agrees on when a backlog item is truly complete. So let me walk you through what's typically included. Reviewed. First, code should be reviewed by another developer. That means someone else looked at it, confirmed it, follows the team's coding standards, that it's clean and understandable, and that comments are in place. If anything was messy or unclear, it should be cleaned up, what we call refactoring, before we move on. Unit tested. So all unit tests for the piece of code should have been run and they need to pass. No exceptions. This ensures that individual pieces of logic are working as expected. After the code is reviewed and tested, it needs to be merged into the main code base. That's continuous integration in action, making sure the new work fits smoothly into the overall system without breaking anything. Once everything is merged, the integration tests run. So these are broader tests that make sure the components all work together correctly, not just on their own. And finally, if it's time had acceptance, this time is the acceptance criteria, like something the product owner requested. It should be verified and approved. The PO or sometimes the team confirms yes, this feature or task is complete and it meets expectations. So this checklist becomes a kind of quality gate. Unless all these steps are done, the task isn't really finished. That keeps the product stable and helps the team build trust with the stakeholders. Everyone knows that if a feature is marked done, it's really done. Although we've reached the end of the sprint, and that means it's time for the sprint review. This is one of the most important meetings in Scrum because it's where we take a step back and ask, did we actually achieve what we set out to do it in this sprint? During this review, the team evaluates three key things. First, we check whether the sprint goal was met. This isn't just about completing tasks, it's about delivering real value based on what we committed to. Second, we talk through any issues or roadblocks that came up during the sprint. Maybe something unexpected popped up, or maybe a dependency slowed us down. The point here is to learn. And third, we reflect on how the team work together. Were communication and collaboration effective? Was the process smooth, or are there areas we need to improve? Now, one person plays a key role in this meeting, the product owner. Their job during the sprint review is to confirm whether the sprint goals has actually been met. They have been working closely with the team, so they are in a good position to say, yes, this is what we needed. Or if something's missing, to give that feedback. The product owner also verifies that the items the team committed to, the ones they pulled into the sprint backlog, have been fully delivered and are working as expected. So to summarize, the sprint review is not just a demo or a status report. It's a working session with feedback, learning, and decision making. And it gives us a chance to course correct before the next sprint begins. So let's step back for a second and think about how Scrum was originally designed and how the way we work today has changed. Scrum started out with a very specific assumption that the team was co-located, meaning everyone was working in the same physical space. The whole idea was that formal communication, just turning to someone at their desk or having spontaneous hallway conversations, would keep everyone in sync. Daily stand-ups in person made perfect sense in the environment. But today, we are not all working in that kind of setup anymore. A lot of teams are now remote or hybrid. Some people are part-time, others might be in different time zones or juggling multiple projects at once. And some folks might work flexible hours, specifically if they are caregivers, parents, or managing different life schedules. So what does that mean for Scrum? Well, it means that relying only on the daily Scrum meeting to collaborate, the team doesn't always work. We have to adapt. We might need to supplement daily stand-ups with asynchronous updates like Slack check-ins, shared dashboards, or team boards in Jira or Trello. The key takeaway here is that while the core ideas of Scrum are still valuable, like transparency, alignment, and communication, we need to adjust how we do these things to match the realistic of modern work. Now let's talk about how a Scrum team interacts with people outside the team, what we called external interactions. In Scrum, there is actually a very intentional boundary between the development team and the rest of the world. The developers aren't expected to juggle emails, sit in the meetings with the stakeholders, or constantly shift gears due to outside requests. Their job is to stay focused, fully locked in on building high quality software during the sprint. So, how does communication happen with people outside the team, like customers, marketing, or upper management? That's where the Scrum Master or product owner come in. The product owner acts as a voice of customer, and they handle our communication about requirements, feedback, and priorities. And the Scrum Master, on the other hand, serve as a buffer and a facilitator. They protect the team from the distractions and help remove obstacles. This setup is designed very purposefully. It allows developers to focus on what they do best, writing and testing code, without being pulled in a dozen directions by external noise. So, in a way, the Scrum Master and product owner act like a shield. They absorb the communication load, filter it, and only bring it to the team what's actually relevant to the sprint. And that's how we protect the team's focus, follow, and productivity. Let's take a look at this visual. It gives us a snapshot of all the areas that fall under the umbrella of project management. And as you can see, it's not just about managing a schedule or checking off tasks. It actually touches on three key areas: reporting, administration, and people. So, first, reporting. This is what most people typically think of when they hear project management. It's about keeping track of budget, staying on schedule, monitoring risks, and communication about problems or blockers. And of course, giving updates on progress. This kind of reporting is essential to keep both the team and external stakeholders informed and aligned. Second, administration. So this is the behind the scenes work that keeps the project legally and functionality, um, and financially on track. It includes things like working with finance, ensuring compliance with company policies, handling procurement, which means ordering tools, licenses, or services, and serving as a liaison when with other departments. And finally, people. This area focuses on the team itself. A project manager often deals with scheduling around vacations or absences, reviewing work quality, and sometimes even helping with hiring or onboarding. It's also about keeping an eye on team health and making sure everyone has what they need to do their job well. So, overall, project management isn't just technical or administrative, it's also highly people focused. A good project manager balances all three of these areas. They support the team, communicate clearly, and make sure the project stays on track in every sense, not just by the numbers. So let's review the whole section, key points part one. So here we're looking at the bigger picture of the agile development and two of the most well-known approaches within extreme programming, XP and Scrum. Agile itself is all about delivering software quickly and efficiently by working in short cycles, what we call iteration or sprints, and reducing unnecessary overhead. Instead of spending months planning everything upfront, Agile teams move quickly, learn from feedback, and adjust as they go. So now let's break down the two and review the methods. We already talked about those. XP is one of the earliest Agile frameworks, and even though we don't always talk about it by name anymore, it introduces some practices that have become industry standards. So and a few of big ones of those is user stories, simple, clear descriptions of features from the user perspective, test first development, also called test driven development or TDD, where you write the test before you write the code, continuous integration, regularly integrating code into a shared repository, to avoid conflicts and catch bugs early. So XP is a very engineering focus. It's about how we write and test code. On the other side, Scrum is more about how we organize and manage the work. It gives us a structure for planning, tracking, and reviewing progress without dictating how the code should be written or tested. In Scrum, the team works from a product backlog, which is just a prioritized list of tasks or features. During each sprint, the team pulls a subset of those items and works on delivering them as a potentially shippable product increment. So, XP engineering practices, Scrum, more team organizing and project flow. And many teams actually use a blend of these two, Scrum to manage their work and XP practices to ensure they are building high quality software. And also, if we wanted to wrap up by bringing it all together with one of the most fundamental concepts in Scrum, which was the sprint. And the sprint is a time box development cycle, usually lasting anywhere from 2 to 4 weeks. And the goal is simple. By the end of each sprint, we should have a working product increment, something that fully developed, tested, and potentially ready to ship. No additional polishing. No, we will finish it later. It's done. Now, how we get there? The key is that the Scrum teams are self-organizing. That means they don't wait around for someone to assign tasks. They plan and manage their own work collaboratively. Decisions about how to get things done are made within the team by not top-down management. And here is a really important point. Even if a team doesn't follow every single detail of the Scrum framework, they can still get huge value from core Scrum practices like maintaining a product backlog, working in fixed length sprints, and encouraging organization and team ownership. So these core ideas are so flexible and effective that you will see them used in many different agile environments, even when the team isn't doing pure Scrum. So whether we are using Scrum fully or blending it with something like Kanban or XP, these principles still apply. Thank you very much for being with me during this reviewing all agile methodologies.